Welcome to Hypotheses. So when we're doing a hypothesis test, testing a claim, the whole point is we have something that we wish to test. So we have our hypotheses. Um, the idea here is we will have a base assumption, which will be our null hypothesis, and we will have a sort of hunch, something that we are, a side we think that it might lean towards, which would be our alternative hypothesis. So the idea is we have a base assumption, which will be our null hypothesis. And then we also have, sorry, I did that too high. So we have a base assumption, our null hypothesis. And then we also will have sort of a hunch for which a side we think it might lean towards instead. So we have a hunch that something else may be true. And this is our alternative hypothesis. Mathematicians and statisticians are extremely lazy. We like to use symbol notation whenever we can, so we don't have to write out the words. So the null hypothesis, we will denote H for hypothesis and then a 0, which is null. And then for the alternative hypothesis, we will use H again for hypothesis and an A for alternative. So we're going to look at the same research questions from our previous video. Do California community college students average more than 20 hours of work a week? So we have a hunch that they average more than 20 hours of work a week. So our hunch has a lean to it. So this is our hunch or our lean. So this will be our alternative hypothesis. So for our alternative hypothesis, we will simply state that California community college students average more than 20 hours of work a week. And I need to pause the video. I'll see you. Our null hypothesis is almost the same as the alternative hypothesis, but we take out the lean and make it an equality instead. So for our null hypothesis, we will have the same statement, California community college students average, but now instead of more than, we will just do the average, precisely 20 hours of work a week. So to go from the alternative to the null hypothesis, we just remove the lean and turn it into equality. So we turn the lean into equality. All right. We also can do these in symbols. So for our alternative hypothesis, the average, which we denote with mu for the population average, is assumed to be more than 20. For the null hypothesis, we take that same statement and we just assume that it's equal. The mean is equal to 20. All right, for this next problem, are the majority of California community college students part-time students? So again, just some key thing to remember, the majority means more than 50%. Right. When we do this in words, we don't need to worry about that. When we do symbols, we will need to translate to more than 50%. So our lean is precisely are the majority or are more than 50%. That is our lean. Or our hunch. We're leaning that it's more than 50% as opposed to being equal to 50%. So our alternative hypothesis would be the statement with the lean. So the majority of California community college students are part-time students. Our null hypothesis, we take that same statement and we switch it to equality. So again, this is majority is more than 50%. So our more than 50% of California community college students, part-time students. And then our null hypothesis would just be that flat equality, so 50%. So 50% of California community college students. Hi. Are part-time students. Then putting this in our symbol notation, our alternative hypothesis, we are looking at percentage or proportion more than 50%. For proportion, we use P for our population proportion. And we are saying that P is greater than 50% or P is greater than 0.50. For our null hypothesis, we are assuming that P is just flat out equal to 0.50. Next up, are UC students less likely to work during the school year than California community college students? So this one we have two populations. So when we do symbol notation, we will need to denote that. But before that, we have our lean. Less likely to is our lean. We are dealing with proportion, but for our wording or sentence form of the hypotheses, we can leave it in this format. So our alternative hypothesis would be that UC students are less likely to work during the school year than California community college students. And the null hypothesis is that they are equally likely. So UC students are equally likely to work during the school year as California community college students. So our hypotheses, our null hypothesis, we are dealing with proportion, whether or not someone works during the school year is a categorical variable. And we have that the proportion of UC students who work during the school year is the same as the proportion of community college students. Versus for our alternative hypothesis, we have that proportion for UC students is less than the proportion for community college students. And then for our last question, do UC students average fewer hours of work a week than California community college students? We are looking at the average fewer. So there is our lean. We are talking about average. Our alternative hypothesis would be that UC students average fewer hours of work a week than California community college students. And our null hypothesis would be without the lean, they average the same hours of work. So UC students average the same hours of work a week as California community college students. So again, in this problem, we are talking about average. Our null hypothesis, we are claiming that the averages are the same. So for average, we use mu. Mu for the UCs is equal to mu for the California community college students. Whereas for our alternative hypothesis, we are claiming that mu for the UCs is less than mu for the California community college students. So that is our sort of how we go about determining the hypotheses from research questions.